Good morning, everybody. How we doing? Hopefully you're doing all right. Ready to work on a little math? Whoop, whoop. Okay, let's get this. So yesterday we did some combining like terms. Well, let me switch this over here. We did combining like terms, right? We could only combine our x terms together. Our x squareds only went with x squareds. Our x's only went with x's. And we had something else. Oh, that's right. Our A's could only combine with A's, and our B's could only combine with B's. So we can't mix those two together, right? Right. So we did some stuff on the back. You probably need a separate sheet of paper to draw it all out. Okay. Well, we don't have to draw today. That's good, right? But we are going to use the order of operations to solve some problems. Remember the order of operations, we have parentheses, exponents, and then we multiply and divide, and then add and subtract from left to right. So I'll even write that up here at the top. Parentheses, exponents, multiply, divide, add, subtract. We do those from left to right. All right, so if division comes before multiplication, we have to do that first. It's just the way it works. All right, now while we're doing this, we're going to combine yesterday's combining like terms and only like terms. So it has to have the same last name. You have 3A plus 4B. Well, one's last name is A, the other's last name is B. Different last name, we can't combine them, right? The answer to that would stay 3A plus 4B. Let's look here. These first three are done for us, but that's okay. They're good examples. We'll do another couple of examples together, and then I'll set you guys on your own. I'll do one from each row. How's that sound? I'll do a total of 4 examples, which means you guys have 8 problems to do on this page, and then same on the next page. I'll do 4. You guys can pick up the rest. Okay, here we go. So we have 5 parentheses, 4A plus 2A. Okay, parentheses are what has to come first. So we do what's in the parentheses first. 4A plus 2A. They have the same last name. They're both A numbers, right? So we can combine them. 4 plus 2 is 6, right? Okay. Now when we multiply, we can multiply across numbers. I know it's a loophole, it's tricky, it's one more thing to try and remember. And why can we multiply them but we can't add them? I know. It's just one of those things that you've got to remember. Okay. So this is like saying that we have 6 A's to add together. You could think of it that way. I guess there's 5 sets of this that we're adding together, or just 5 times this. 5 times 6 is 30, and the A just comes down. Or like I said, you could do 6A plus 6A plus 6A plus 6A plus 6A. Those are A's. My pen's not working quite right. It's cold in my garage this morning. Sorry. Add them together. 6 plus 6 is 12, plus 6 more is 18, plus 6 more is 24, plus 6 more is 30A. So you can multiply it. 5 times 6 is 30. Or you can add. If adding it helps you think that, yeah, I can do that, that makes sense, then go for it that way. Over here, we don't have parentheses, but we have multiplication and subtraction and then multiplication. Remember, we have to multiply first before we do any add and subtract. So 10y times 2y. 10 times 2 is 20. And y times y is y squared. Y plus y is just 2y. Y times y is y to the second power. I know. It's a little rough. When we did powers before, it's been a little while, so it's easy to forget those rules. 10 times 2 is 20. Y times y is y squared. Minus, bring that minus down, 5y times 3y. 5 times 3 is 15. Y times y is y squared. But now these are both y squared terms, right? So we can do 20 take away 15 and get 5. Y squared. Still works, right? Yeah. We have a 10x minus, parentheses, 9x minus 2x. Okay, start with that. Parentheses first, right? 9 take away 2 gives us 7. Of course, it's both x terms, so it's 7x. We'll bring the rest of us down. 10x take away 7x gives you 3x. All right, so there's 2 sets of boxes here. This is printed out yellow on my sheet. I think it's like orange on the screen. This is where you can write down your first step of the problem. And then the blue box is where you write your answer. So in this case, I'm going to do 7 times parentheses 9x minus 3x. So I have to do what's in the parentheses first. So I'm going to copy down 7 times, what's 9x minus 3x? We're taking 9 and subtracting 3, right? 9, 8, 7, 6. 6. Don't forget that x. 7 times 6x. Okay, if you have a timetable chart with you, or if you have a calculator handy, can you tell me what 7 times 6 is? If you don't have one, go get one, because you're going to want one today. For real. 7 times 6 is 42, and then we just keep the x that's attached to it. That's our answer. All right, well, let's try this one. Actually, I should have done this one because that's much more complicated. I said I'm going to do a total of 4. All right, I'll do this one. Sorry. We have 5 times 3x squared minus 2x times 4x. So we have no operations to complete in the parentheses. We have parentheses, but there's nothing to complete there. It's just multiplication and subtraction. We have to multiply before we subtract. Whew. Sorry about that. Whew. Here we go. So 5 times 3, 5, 10, 15. So in my yellow box, I'm going to write 15. I'm going to bring that. There's nothing else attached to that 5, right? So it's like 3x squared plus 3x squared plus 3x squared plus 3x squared plus 3x squared. Yeah, the x squared comes along with it. 15x squared. I bring down my minus. Now it's 2 times 4. 2 times 4 is 8. Now here we have an x times an x. And just like we talked about up here with this one, y times y give us y squared. Sorry, x times x is going to give us x squared. I'm trying to do this video without my coffee. What am I thinking? Now do they have the same terms? X squared and x squared? Yes. They have the same last name, the same terms. So we can subtract these. 15 take away 8. 14, 13, 12, 11, 10, 9, 8, 7. 7, and put our last name on it, x squared. Okay? Only if you multiply does that become squared. If you were adding 2x plus 4x, the x would stay the same. I know, it's complicated, it's tricky. I'm sorry. I wish it were easier to remember. I really, really do. Let's look at this one right here. 3a minus 7a minus 2a. We have parentheses. Let's do what's in the parentheses first. 7a minus 2a. 7 take away 2. Just count back 2 spots. You get 5. And bring down this part. 3a minus 5a. 3 take away 5. Now remember, you're taking away more than what you've got to start with. Like you have $3, but then somebody buys you lunch, so now you owe them 5. You pay in the 3 that you have, but now what do you still owe? Still owe $2, right? So we have a negative 2a. Whoa. Didn't see this one coming. 3x times 8y plus 2x times 2y. Those aren't subtractions, those are multiplies. All right, so when we're multiplying, we combine those terms together. 3 times 8. If we were adding 3x plus 8y, we couldn't do it, right? Because those are different terms. When we're multiplying, we can multiply them together. I know it doesn't seem fair. It doesn't. 3x times 8y. 3 times 8 is 24. And x times y becomes xy. Only when you multiply can you do that. Plus 2x times 2y. 2 times 2 is 4. X times y, xy. Now we're done multiplying. Now we're going to add. Is xy the same term as xy? Yeah, it is. So we can combine those. 24 plus 4. 25, 26, 27, 28. And then xy. Okay. Now if we have, I'm going to work out this one right here. We have x squared times everything in those parentheses. X squared times 4x, and x squared times x. Just x squared by itself is like having an imaginary 1 in front of it, right? So 1 times 4, that stays the same, 4. Then x squared times x. X squared is like saying x times x. And we do that, times x again. How many times is x multiplied by itself? We have x times x times x. There's 3 of them, right? That makes it x to the 3rd power. Only when you multiply. When we add, we just combine those terms to make 3x. When we multiply, it's x times x times x. That makes it x to the 3rd power. X plus x plus x, we're just adding 3 x's. When we multiply them, it's x times x times x. X to the 3rd power. And then we bring down our plus sign, x squared times x. Again, there's that invisible 1. 1 times 1 is 1. That stays the same. X squared times x. X squared is x times x times x. So you have 4x to the 3rd plus x to the 3rd, which has an invisible 1 attached to it, right? Really skinny, the invisible 1. There we go. What's 4 plus 1? 5. x to the third power. Let me right over here again. X plus x plus x equals 3x. X times x times x equals x to the third. This is saying 3 times x. This is saying x times x times x, x to the third power. I'm trying to think of a better way to explain this. When we get back together on Monday, this is what we'll be hitting hard. Okay, we'll be going over this and why it works like this. Okay? Otherwise, you just have to remember only add or subtract the ones that have the same letter behind it. So I'm going to do 5 of these with you. I did a bonus one. Let's do some over here on page 2. Okay? They're going to work the same way. We're only going to combine the like terms. But we do have some that we're going to multiply together. Okay? It's going to be all right. We'll get this. Here's the examples that they did. They combined what was in the parentheses first. Boom. That became that. Then they brought the rest of it down. So 3x squared plus 6x squared. They both have an x squared for the last name, right? Combine them. 3 plus 6 gives you 9. And bring down the variable, the x squared. And you're multiplying all that by 2x. 2 times 9 is 18. And x times x squared. X squared equals x times x. So you have x times x times x. Right? X times x, boom, boom, times x is x to the third. Okay? So they did here, too. 3x squared times 4x. 3 times 4 is 12. X squared times x. Here's x squared. Here's x squared. Times x. X times x times x. X to the third. That's what you got. Same over here. 5 times 2 is 10. X times x times x. X to the third. Now we're subtracting. When we subtract, our like terms stay the same. We just subtract the big numbers in front, the coefficients. 12 take away 10 is 2. Bring down your x to the third. I know, guys, it is confusing. I'm not saying this is easy at all. Okay? But that's why we're taking our time and trying to learn it, trying to chug through it. 5xy minus 4xy minus xy. Well, that minus xy has that invisible 1 in front of it, right? So 4 take away 1 gives you 3xy. 5xy minus 3xy. 5 take away 3 is 2. And our xy's stay the same and come down. Okay. When this one, you combine your 3 times your 4. All right. 8xy plus 3 times 4 is 12. X times y is xy. Okay? I'll let y'all solve that one. I just set it up for you. The next one you guys can set up. I'm going to solve this one right here. 5a to the third power times parentheses 8a minus 6a. Remember, we do parentheses, exponents, multiply, divide, and add, subtract. We do these from left to right. So if there's addition in between our multiplication and division, then we have to finish doing multiply, divide first before we do add, subtract. But first off is the parentheses. So this 8a minus 6a. 8 take away 6, we have 8. 7, 6, 5, 4, 3, 2. There we go. 2a. 5a to the third times 2a. 5 times 2. You count by 5. 5, 10, right? 10. Then we have to do our a to the third times 2 times a. A to the third power is a times a times a. So if I do that times a times a times a times a. How many a's do we have there? 1, 2, 3, 4. A to the fourth. I know, it's not easy. It's not. I'm just asking you to try it. This one's complicated. That's okay, because we're going to do it. We're going to get it. 5x squared times 4x to the third minus 6x to the fifth. We have parentheses, but we're not solving anything in the parentheses. This is just a fancy way of saying this times this. Okay. 5 times 4, 5, 10, 15, 20. 5x squared, x times x times x to the third. So times x times x times x. How many x's do we have altogether? Sorry, here's x squared times x to the third. How many x's do we have there altogether? 1, 2, 3, 4, 5 of them. Guess what? Oh, whoops. I wrote that in the wrong spot. That's part of my work it out. Okay. How many x's do we wind up over here? 1, 2, 3, 4, 5. 20x to the fifth minus 6x to the fifth. X to the fifth and x to the fifth, are those the same terms? Yeah, they are. So the only thing we have to do is do 20 take away 6 and then put that at the end of it. What is 20 take away 6? Well, for the sake of time, I'm going to say it's 14. Then bring down your x to the fifth. This will be good and complicated. 3a times 7a to the fourth plus 4a to the third times 3a squared. That's got me shaking my head at that one. Like, what in the world just happened here? I know. All right. 3 times 7 is 21. I'll figure out my a's here in a minute. Then we got a plus. 4 times 3 is 12. We'll figure out our a's here in a second. Okay, so we have a times a to the fourth, which is a times a times a times a. That looks like a 9, but it's really an a. But the other way I make them, they look like 2's. So I don't know. There's not a good way for me to do a's. How many a's do we have here? This is a times a to the fourth. 1, 2, 3, 4, 5 a's. Guess what? 21 a to the fifth. Over here we have 4a to the third. A times a times a times a to the second A times A. How many A's do we have? 1, 2, 3, 4, 5. Guess what? I did it again. Dang on it. 21 A to the 5th plus 12 A to the 5th. See, I don't have a backspace button where I could delete that. Oh well. So our A to the 5th and our A to the 5th stay the same. All we're going to do is we're going to combine 21 plus 12. What's 1 plus 2? 3. What's 2 plus 1? 3. So we have 33 A to the 5th. Okay. I'll do this right here in the middle, since those are similar to what we've already done. Those are 2. We're just adding and subtracting. We don't have to combine the variables at all. This we're doing, we're multiplying. So 5x squared times 2y squared minus 3xy times 6xy. Shoo! Okay. 5 times 2 gives me 10. I'm going to skip my variables for just a minute. 3 times 6 is 18, right? Right. I'll skip those for just a minute. I have x squared times y squared. I can't really do anything more with those than just write them down like it is. Right? It was x squared times x squared. I could combine those to be x to the 4th, but I can't do it with this. I just have to write it down like it is. So 10 x squared y squared. Now over here, we have 3xy times 6xy. We did the 3 times 6. Now we have x times y times x times y. How many x's do we have? 2. So that becomes x squared. How many y's do we have? 2y squared. Hey, wait a minute. Now those match up. Crazy. I know, right? But now we have 10, take away 18. So we're taking away more than we really had to start with. If you have a number line going on, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 1, 2, 3, 4, 5. Negative 6, 7, 8, 9, 10. So I got 5, 10, negative 5, negative 10. If you ever need a number line, you can always draw one on the side of your page. Okay? So we're going to start at 10. We're going to subtract 18. So starting here at 10, I'm going down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. Puts right here on this spot. There's negative 5, negative 6, negative 7, negative 8. Okay. Negative 8 x squared y squared, because those will stay the same. All right, guys and gals. Try the rest of them on your own. Let's see what you come up with. Okay? I think you've got it. I think you understand it better than you think you understand it. I have complete faith in you to get this. All right? If you're stuck, go back and rewatch the video. If you're still stuck, join the Google Meet. If long as before noon, catch me there. We'll talk about it. I'll do what I can. All right? Peace out, homies.